we'll see. I'm watching it in the corner. It usually takes a few seconds to upload, but welcome everyone to our very first Archi-Tech Talks live. This is a new feature that we're going to be doing, Bruce, to basically give people a platform to kind of do talks, share their projects, talk about the technology they're doing, any kind of innovation they're doing in this space. I can see now on my second screen, I think we are coming to life. So um, we are live. We're officially live, Bruce.
Great.
So yeah, this is going to be a talk where we're going to invite different people on for around a 30-minute talk, Q&As. You guys are more than welcome to put your questions as you go in the comments. We'll see them here, and we can do a little Q&A at the end of it. And today I thought the best way to kind of kick this off is to have Bruce on, and Bruce and I talk about what we're doing at Facit Homes.
Cool.
Many of you may know that as well as ATN, I'm also working at Facit Homes with Bruce, and we're trying to disrupt the housing space, which is a space I've always been super interested in. And Facet have been the innovators in the space for a long time. So I thought is the perfect way to start the series is to get you on, Bruce,
Great.
and talk to people about what we're doing.
Yeah.
So our very first guest, Bruce Bell, CEO and founder of Facit Homes. You've been pioneering the space for 16 years now. You got started in like 2007.
Yeah, maybe before it was fashionable.
Exactly. Yeah, I'd say one thing you were a little bit ahead of your time. Is
But yeah, I mean, I think like you say, the space is ripe for disruption. I wouldn't say maybe in the past we've been disrupting because we've just been busy doing our thing, but like now, the sector needs some ideas and bringing to it, and that's what we're doing.
Yeah, exactly. And Fast have already been paving this way for a long time. We'll talk about it in the presentation. And now we're in the process of scaling that up to, deliver houses on a much larger scale. So in this talk, Bruce is going to give you a little bit of talk of, the background of history, the backstory, and where we are today. And I'll give you guys a little bit of talk of where we're going with, as we go to become a tech-enabled house builder. So
Yep.
yeah, Bruce, I'll hand it over to you if you want to
Cool.
share your screen,
Yeah. Oh, that's a good point. There we go.
and
So
we'll
screen.
take it away from there. This is our first live, guys, so I'm sure there'll be some technical challenges. I'm still working out how to be a good host, but I think we're going to go like this, Bruce. So you'll be
Yeah. Okay.
a little box in the corner.
Yeah, okay, so I'm going to give you the backstory to Facet Homes, kind of how we got started, and where we've got to today. So I'll talk a little bit about technology, kind of projects we've been doing, and then obviously Ollie will take over and talk about some of the future stuff. But broadly, Facet Homes started back in 2006-7, which I'll talk about in a second. But today we're a custom home builder. So we do everything from design, manufacture, construction, all the way through to handover. We're one of the few companies operating in the UK who literally does every single part of the home building process for historically for private clients. So I'll talk to you a little bit first about how we got started. So I actually originally trained as an industrial designer and started actually working on products and manufacturing processes in my BA. But my first job was at Norman Foster's Architects in the late 90s. I was there for a few years using digital design, digital tools within the studio. And this was one of the kind of first projects we worked on, which was the Chaser Futura project in St. Moritz, which was probably one of the kind of key projects for me, which is digitally designed, digitally manufactured in this case, timber, residential as well. So this was maybe just the start of some of the ideas that were kind of tinkering around my brain. After Norman Foster's, I went to the Royal College of Art and I was making products and components and experimentations and sculpture as part of the design products course there, all around kind of experimenting with digital manufacturing techniques. So after the RCA, I decided that I actually ran an architecture practice for quite a few years, very traditional architecture practice, and we kind of decided at that point there were some opportunities for the use of digital manufacturing in homes. So in this is me back in 2007. This is really the very first part of the process where we built a proof of concept for using CNC manufacture for the production of homes, which was funded at the time from the GLA. Um, and so we built this, we designed it all on the computer, and we manufactured it, and it pretty much came out exactly as we expected. So from that, we decided we could try and make this into a business, and we went out, we got some customers. We're very much kind of finding our way as we went, and we decided to see if we could do it for real. So right back at the beginning, we didn't have a workshop, we didn't have a manufacturing facility, and we decided that we would use this technology, this CNC manufacturing, but bring it to the construction site because we thought we could, and it would save us money on transport and shipping, and it would save us money on rent and having a factory space. So we've been using this on-site manufacturing process, and I'll just kind of open this up if I can. So the manufacturing process is we bring the machine with us to the construction site. We drop it down, sits in a 20-foot shipping container. We bring the materials straight from the dockside, put them on the machine, and then we manufacture there and then on demand. So we're remotely operating and loading in the files from the design studio. We're cutting things out super precisely to 0.1 of a mil accuracy. Really simple technology to use on site, so very little training, usually with low skilled laborers. Um, and we're building in a very traditional process where you manufacture and install. So you're working within the norms of traditional construction, and we're very much interested in the transformation of normal processes with technology rather than the kind of revolution where we say, oh, everything has to be done offsite. So with this process, it's incredibly efficient, keeps costs down, and we reduce the amount of components that are held in inventory, and we just go from machine to install. So this is the process that we've been using really since on site since 2011. And we have to deal with all the practical stuff like shipping and transport. And the very first time we moved the machine, we found that it kind of moved down the other end of the container. So we learned very quickly that you have to strap it down and make sure everything's secured. And let's just do this again. So from after that, other than the machining aspect, we've always had to deal with the brutal realities of construction. So actually dealing with groundworks and civils and utilities, and this is actually the jig that we made for the very first pile installation. We CNC manufactured a jig to see if we could guide the pile into the right place more accurately. So we're constantly asking ourselves, how can we use digital technology to improve the process? The very first homes we did, this is homes 1 to 4 from 2009 to 2012, were more collaborative working. They weren't always our designs. They weren't. We were quite often working as a timber framer and not as the kind of overview of everything. And after that, the outcomes we found were quite variable. Sometimes it would come out really well, and sometimes it wouldn't come out that well. So we decided that at that point we would take control of the whole situation and become contractor as well as designer and manufacturer. And the philosophy that we kind of came upon at that point was to add consistency and kind of use the philosophy that I have in my training as an industrial designer to think of the home as a product. So every home is conceived as a holistic product where they're always made of the same fundamental components. So we've got the same foundation system, same heating, same roofing, same windows, same door sets. And then in the middle, we've got the same superstructure. So this is the bit that we manufacture that we call the chassis. So like the chassis of a car, it's ready for the components to fit to it. And we reconfigure these components through the digital design tools that we use. so we don't have to have a standard typology. So it's much more flexible than people kind of associate with the likes of modular construction, but it brings a lot of the associations in terms of accuracy and cost and management. So this is home number 5, which is 2013, which we kind of really think of as the first proper Facit home. It's the first one where we were in complete control of the whole process, and we had a lot of fun, manufactured cladding systems, a staircase, shading, fitted out the whole house ourselves, custom made, lots of custom made items in there. And it worked really. It worked as a both as a business and as a end product. So from the back of that, we decided to try and grow this into a more established business. At that point, we were we were using Revit, so using building information modeling, but we weren't particularly making that much use of it. So off the back of it, we decided that we would try and make more of the BIM model than most architects would traditionally do. And we set about producing what we call engineering grade BIM, so really highly tuned manufacturing digital assets that you can go direct from the digital model into manufacture with the same data set. So a single source of truth, much more accurate in terms of how representative they are for the final product, down to the millimeter. As well as all the parametric aspect that comes with the BIM. So we're able to kind of downstream all this information from the BIM model directly into manufacture, and really go from that digital to a real physical component as directly as possible. So over the years, we've produced thousands of different types of components. We've cut 37,000 sheets of plywood, 20,000 hours at least of research and development. And the way we operate is to kind of try and use the system to determine as much as possible all the other components around it, much like that's why we call it the chassis. And we're thinking of it more of as a philosophy than a specific building system. So we're able to modify the components to whatever particular style or junction or open panel or closed panel, whatever it happens to be. So we're constantly evolving it as a methodology. So these are homes number 26 to 6 to 28. So this is the kind of latest cohort, if you like. And we've been building all this time, trying to constantly improve our processes. But you can see that the each house has got a very unique look and feel to it, where they've been designed specifically for the site, and the technology kind of wraps around the design requirements rather than vice versa. So we can think of the house and the design requirements, the site requirements, the customer, and make sure that each house is exactly as it needs to be and not be kind of defined by our tools, if you like. So we've also during this process had to deal with all these interiors as well. So we've actually been contracting this, choosing the specification, understanding products, installing it, dealing with the reality of defects and finishes and good quality items. It's, you know, and we always think about these things of how can we use digital technology to improve these processes with a quality control process or a standard way of contracting or tendering, whatever it happens to be. So again, you'll see there's a lot of different varieties of style and aesthetics, which is broadly driven by the client. But the way that we approach it is that we can accommodate that. So sitting beneath the way we operate are a bunch of systems that we've built. So we have a really accurate costing system that costs within 1% accuracy. We've got remote management system because we actually uniquely to us, we manage projects and deliver all over the UK from our central headquarters. So we built up in Scotland recently, over in Suffolk, Chichester, all over the place. We built ourselves some really amazing supply chain management systems, and all of them are kind of interlinked, if you like. So there's no silo between any of the systems as much as there is any of the staff working in the business, which makes it incredibly efficient and incredibly accurate. You know, one of the things I noticed as a industrial designer by training is just how fragmented the processes in a traditional architecture process where separate architect, separate builder, separate suppliers. Really, the manufacturer's perspective is your role is to bring it all together into a single solution. So that's what we do. We've also, people, particularly back in the day, were asking us, why would you be manufacturing on site? That's crazy. It doesn't make sense. And actually, we spent a few years um, manufacturing in a factory. And actually, what we found is we spent most of our time stacking, tessellating, shipping pallets of components, handling them, unhandling them, and then having sites littered with too many things. And so actually what you build up is a lot of inventory and a lot of physical stuff that you've got to manage and physically move around. Um, the beautiful thing about the on-site manufacturing is it just removes all of that stuff. You just don't, it literally goes from the machine to installed. You don't have the thing hanging around for a while that you have to deal with or ship or think about. So we really understand the benefits of the on-site manufacturing. The on-site manufacturing could be local as well. Sometimes it's not practical to have it on-site. We've also done a lot of experimentation with civils, groundworks, foundation systems, slab systems as well. And we're constantly thinking about, how can we get accuracy out of it? How can we use less concrete? This is interesting. This is a system that we use where we cut through a template to try and mark on the slab. This has been, that was back in 2015. This has been superseded actually. Just recently, we tried out the HP print system, which Ollie might mention later. But it's the idea of how do you get this design information physically down onto the site, be that a cut, built asset or a drawing bit of information. The foundation system that we now use is super insulated raft system, and it's very simple and accurate, and we're kind of often thinking about that relationship between the design details, the product system, and its constructability and its quality management as well. So all of these things come into play. This system we like because it's very clean, easy to understand. The drawing information is also very clean, and this is one of the drawings compared to other foundation systems that we use. This is relatively simple. And if it's simple to spot errors. There's less chance of it being constructed wrong, because at the end of the day, humans are putting this stuff together, which is fallible. We do a lot of leveraging of the digital design files for other manufacturing as well. So we'll do aluminium window pods, staircase details, custom made components. So we do a lot of metalwork fabrication, and we have a metalwork company who we work with who will send our laser cut nested files, which will come straight out of our production system, and we send it to them. They'll cut it and then fold it according to the crop marks that are already on it. So it's our product made with somebody else's machine, as opposed to our product made on our own machine. So the business today at the moment, very broad overview. We've done £30 million worth of construction, 28 quite large properties. That's 74,000 square foot of home. We'll generally do them at about half the time of a traditional contractor. Particularly the speed where we really win is the time it takes to go from planning permission to putting a shovel in the ground. Often people miss how long it takes to do your technical design, choose a contractor, negotiate, mobilize, realize it's too expensive, redesign. Our process is designed to just shorten that down to the absolute minimum. So that's broadly what we look like today, and that's the quick backstory of Facit, if you like. I think I'm going to flip over to you now, Ollie.
Yeah. I'm just gonna hang on. Let me share my screen. Do a little flipperoo. I'm also producer whilst I'm doing doing this. Yeah. So I think what Bruce was saying, I thought I'd add this, Bruce, where I'll just talk about, like, one of the things I really like about this is seeing how you go from design to the actual construction is incredibly accurate. And this is a product that we've just completed. This was a render that we did in the design process. This is the BIM model. This is it under construction. And in fact, you can have a little peek inside this actual house and see what the chassis actually looks like inside. So you see all the components assembled together. We've got the Curto beams. You can see all the MEP, all the ducting, the windows, all fits into the chassis as exactly how Bruce was talking about. And you can really see the intricacy of the chassis. And then you go to the completed project, and this is not a professional photo, but you can see it's not at all. It's almost a one for one, which coming from a design firm going into construction, that's very rare that your render to reality is so accurate. And I also really like shots like this where you go all the way from the logic of the component to assembling the entire frame, and you go again from render to reality incredibly. There's almost no difference, right? Because we're solving so much of it in the BIM process. And
Yeah, it's
also
quite
just
like I find it quite ghostly sometimes when I go and visit a project, and I've never been there before, but I know the house intimately in terms of it's like I know it millimeter precision because I've
yeah,
looked around the model so many times.
exactly. And this is the process. You can see the foundation system, the components, the waterproofing, and cladding. We can essentially do whatever. Um, so yeah, we're now, Bruce and Facit, we've developed this technology over the last 16 years, and we're now, we've kind of perfected that process and our technology, and we're now scaling it to a much larger scale. And this is where we see we can be building, much larger developments, multi-unit schemes, and essentially we're transforming to become what we call a tech-enabled home builder. Um, One of the questions is also why and the context that we're doing it in. So here in the UK, and the sentiment is pretty much the same globally, is the housing and building sector is going through a crisis. Traditional construction is really struggling. It's has a really a labor skills shortage, which is making building more and more expensive. They haven't really been adopting technology, so there's a real struggle for traditional builders to scale and meet the demand for housing. And at the same time, we've had this new world of modular and volumetric, which in the UK has completely collapsed essentially. So builders like, you see here where you build a giant factory and you assemble or build a big chunk of the building. So typically it was volumetric, where you can see it's almost like a shoebox of a house gets made in the factory and shipped to site, has just collapsed. The fundamentals of it doesn't stack up, and this isn't just a few companies going bust. This is we're now in the double digits of this point of companies spending hundreds of £1 million setting up a factory and going bust essentially. And so we face this future where we don't really know what the next thing is in the housing space. We need to build more homes than ever before. We need to build them more sustainably than ever before. And I think, Facet have been slowly and quietly disrupting this space and proving the technology that is scalable and actually works from a business model perspective. And, we see our solution is to become a tech-enabled home builder where we have a fully vertically integrated home building essentially platform that we can either use internally or work with other people to enable them to build with our technology. So we have this complete end-to-end solution from design all the way through to construction that essentially enables you to build faster and cheaper than with traditional or modular. And most importantly, it comes at a fraction of the cost of your traditional fixed factory, which we'll talk about a little bit more later on. So the same concept that Bruce described, the home as a product, completely scales up to townhouses, terraces, small apartment blocks. This idea that we can basically uh, build the home as a product. We can build any shape home as well. We're not like these other modular companies that are fixed by a box or shape. Our modular system can just be configured in completely different ways. So customization for us is almost unlimited. So we can build any kind of shape or size of houses. And of course, this is what scaling that up looks like. So that same diagram we just looked at, we've got the same kind of raft idea. We have our components going on, but now in this case, this is a multi-unit scheme. This is one that we looked at. We'll show a little bit later on. The same exact concept applies, same products, the same windows, the same doors go in, and we can clad it in whatever we need to. So of course, part of this process is also continuing to digitize as much of the design to construction process as possible. So this is automating still our D process, which is our process going from BIM to manufacturing, which is now almost fully automated. We're now also experimenting, and this is kind of partly where I came in at the beginning of my time at Facit, where we're saying what automation can we do on the tools that we have? How can we use Rhino Inside to do drawing automation, to go from a design model into a Revit model really quickly? Can we populate our chassis automatically, essentially? Can we go from a surface model all the way to a detailed model and speed up the design process? We've also been in a really, experimental phases of creating prototypes in Grasshopper to look at development feasibility. What does it look like if we put rows of townhouses on a site? How much is that going to cost? How much GFA does it give you? And actually work with developers in the early stage to look at the feasibility of a site, like what can we do, and putting a Facit development on your site. This continued with slightly more detailed studies of townhouses. So how can we put create a configurator for townhouses that enables a bunch of different configurations. This gives us a base which we can then kind of pick into and create custom elements within the design manually, but it still significantly speeds up the beginning process where we're costing and looking at the feasibility of sites and experimenting different types and forms. And of course, the other part is scaling up our key innovation, which is our Microfactory. And so the video that Bruce showed you is essentially our Microfactory 1, where we have a single machine in a container. We've also now developed new Microfactories that give us higher capacity to cut plywood, which enables us to build larger buildings and build them faster. And so now we've developed 3 Microfactories. So Microfactory 1 is the one that Bruce showed you, which we currently use for our homes. Microfactory 2 is essentially 2 of our MPF machines in a larger Microfactory dwelling, where we've got improved assembly and sub-assemblies. So we can use this today with our existing technology to build larger products tomorrow. And then we've also developed a Microfactory 3, which I'll show you, which is in partnership with Facit, that essentially adds automation around the machine. Our Microfactory 2, though, looking at it in a bit more detail, we have this. We have 2 of our containers. So our CNC machine in a container here, which is essentially a way for us to kind of brute force more cutting power. We have multiple assembly tables. We got buffer racks, so the machine can just continue on cutting. And then we've also got sub-assembly stations where we can conjoin components into full wall buildups and also speed up the assembly. And we also want to look into how can we put in membranes on the floor, windows on the floor, so we're not double handling these materials from the ground up to the second floor or whatever it is, and install it on the building. Can we assemble it much like you see a curtain wall facade being assembled? So yeah, we're also looking at small cranes and things like that are really quick to deploy to enable us to assemble the building quicker. The new machine that we've developed in partnership with a company called Facit. So Facit is a automation robotics company in the UK, and we've been working with them to essentially automate our machine. So now we have a 3 container system. We still have our CNC machine in the middle, but around it has a bunch of automation, which I'll show you in a little bit. But this even further increases our cutting capacity and cutting speed, and essentially the machine can just run overnight. And so this third Microfactory that we've developed looks like this. We have a 3 container system. The containers join together. Each one houses its own specific thing. But the idea is still the same. The materials come in, the plywood comes in, it goes through the machine that produces the parts. The parts get assembled into components, and then components get assembled into sub-assemblies. and the microfactory is deployed on or immediately adjacent to the site, as close as to the site as we can get, so that we can go from manufacturing to assembly in the shortest time possible. So each of our new microfactories, the third ones, can deliver 80 to 100 homes annually. To give you a little peek inside, this is our Facit chassis printer with our assembly tables, which are just assembled by hands. You know, we don't have any robot arms or anything like that. We do, of course, want to use technology that we think is adaptable to this space. So augmented reality, right? Can it help to train someone into assembling their first few components quicker, or aid them in, you know, scanning a QR code or whatever it is? We can go from components to sub-assembly. So you can see in the background here, we can actually put larger building elements onto the building and speed up the actual process of the assembly. And it's essentially bringing more and more technology to the construction site to speed up the process. The new machine that we've developed looks like this. So this is a new machine. So in the middle, we still have the CNC machine, but around it, we have a 2D print system, material loader on and off, and a buffer rack. So the print system actually enables us to put instructions on the faces of the components. The CNC machine does its thing. The material gets loaded on and off automatically. And we have a buffer rack, so we can essentially cut the plywood all day and all night long. And it essentially adds all the automation of the manual process of our current machines. You know, when you think about our machines and the chassis printer or the MPF, it's essentially this process, right? It's a single line of production that can produce many different types of components. So we're not just producing one wall component, we can produce walls, a window component, roof components, gutter details. Like it's really detailed stuff. So we're able to create standard components, but we also on products create completely customized components. The new 2D printing capabilities essentially give us this. So if you've ever worked on a construction site and you've given someone a drawing, you can almost guarantee it will not be in the right place. So our 2D print system essentially tries to just put instructions onto the faces of the components. And this opens up a world of adding QR codes or scanning things for dimensions. And we're also experimenting with other people's technologies that enable us to do this. So this is the HP site print that enables us to actually print on the slab as well. So in theory, we would have a 360 degree of instructions on the floor, on the walls, on the roof, to aid the construction process. And as Bruce mentioned, this is something we just experimented with a month ago, right, Bruce? Where on one of our existing products, we used the HP site print to print out the layout of the building on our foundations. Now, you know, our foundations are pretty accurate already, but there's always going to be some discrepancy between the digital and the real. And this is one of those things that allows us to blend between, you know, the foundations, which is the somewhat messy part that on the construction site, and our chassis, which is incredibly accurate. And this enables us to lay these things out. We think we've saved a number of days of our carpenters laying these things out, and it was a pretty cool test, and it's definitely something we're going to continue to use. So one thing to understand about, you know, the fundamental difference between building with a fixed factory and a microfactory, and I'll just go over the 2 points of this without getting too into it. But one is the size of a factory. And so to scale, you can see our microfactory is literally like micro. And the reason that is because most people that have built factories to build from, they just bring inside the way that we build already. So they bring inside the way that we build walls, the way that we build floors or the roof, and you end up with multiple lines of production for each of those specific things. And that's why you need so much space. Eventually they assemble them into a shoebox or something, and then it gets shipped, you know, to site. Ours is the complete opposite. So we have a single line of production which can produce many different components: walls, floors, roofs. So we, rather than having multiple lines of production, we just have a single line, and that's what enables us to be a microfactory. And the other thing which is really key is the cost. So the cost of your factory is going to cost you around 12 million quid. Each of these factories can deliver 100 homes a year. So for your fixed factory, you're going to be spending around 12 million quid paying back finance over 5 years to buy the machinery, rent, transport, all that kind of stuff. And when you think of that per home, that's 120 grand per home is just on the cost of running your factory, essentially. And this is why factories has never really worked. Whereas ours is so low cost per home, it's costing you about 2.5 grand per home or 240 grand per year, which in the grand schemes of building things is almost negligible. And this also gives you a lot of other advantages of, mobility. We can put our microfactories anywhere in the world, essentially. Whereas a fixed factory, you pick a location, you spend years building it, and then you can only deliver projects that are a drivable distance from that factory, right? So, this is the key reasons why fixed factory has struggled over the years and why our microfactory approach is fundamentally something completely new. Of course, as Bruce said, we're scaling our ecosystem as well, our supply chain, our costing modeling, and we now have this fully vertically integrated home building platform. So we can go from development appraisal, looking at a site that we're either going to build ourselves or working with a developer to appraise it and get really accurate costing immediately, all the way to leveraging our Facit Homes brand and actually selling it. We can work with other developers and architects if you have a site already or a design already, or we can also just take it from the very beginning and take it through appraisal and the design process. Essentially, we offer a way to build that is 50% faster than traditional and modular. Where we really save time here is not going back and getting to the tender process, realizing things are too expensive, and then going back to that process. At the very beginning, we know how much things are going to cost because we're the ones that are making them and have all that. And even the modular and volumetric guys, the ones that are left, they often have to wait for time in their own factory to start producing, whereas the flexibility of microfactories means we can deploy them extremely quickly. We can also build cheaper than traditional and factory based. So, much like a home builder has, we have our own products, we have our own framing systems, we have our own supply chain, which we can utilize to build at lower cost and also empower other developers or councils, housing associations to also build at these lower costs that they traditionally wouldn't have access to through a traditional contractor. And this is just a sum of an example of the things that we're looking at right now. Some of these products are sort of our own that we're developing. Some of these are working with other developers that we've just done either feasibility studies for in terms of costing or what our chassis would look like on this product. Some are actually moving forwards and we will hopefully be building in the near future. One of these is the Phoenix in Lewis. This is with a developer called Human Nature. It's going to be the UK's most sustainable development, and we had a look at a feasibility of what it would look like to build with our chassis and actually build these products. So, their first plot that we're looking at, which was designed by Ash Secular, I believe. Really interesting scheme, as you can see, like very unique design, very customized, higgledy-piggledy design, which for a traditional builder would be a complete nightmare. For us, it's actually, we can handle the complexity, and, we're able to very quickly populate the model, build the chassis, go all the way from the structure, the foundations, to the windows, and work out literally how much exactly it's going to cost and how we're going to cost it. Another product, a Home of 2030, which was the winner from the national competition for the Home of 2030. Again, we looked at how we could apply our chassis for this new housing development up in Sunderland and build it using our system. A very similar case also in Sunderland with Sunnyside with a developer called Town, where again we looked at these terraces and these 4-story like apartment blocks, again utilizing our system to enable them to build faster and also build sustainably. Like a lot of these products are trying to hit a net zero target, and our building system is one of the things that will enable them to do that essentially. And then some of the products we've been looking at ourselves is this is a product in Bicester for 10 houses that are, around 250 square meters each. Um, again, this is something that we can now deliver today with the existing technology that we have. We can design it, we can plan it, we can do the placemaking, and we can literally essentially hand you the keys over and even help you sell it. Another product in Oxford, which is for a 5 house scheme. Again, larger houses, slightly higher end of the market, but now we're able to deliver 5 houses on a scheme on a unit. And for the final one, which is really where we kind of see a huge opportunity for us, is this kind of townhouses in London, small plots or backland plots or old parking lot plots. And we're looking at a scheme for 27 homes of 2 to 3 story terraces and townhouses. And as you can see, each townhouse can be somewhat unique or customized. We're even looking into developing our own facade systems that we fabricate ourselves, and we think there's a real opportunity for us to tackle these kind of sites, particularly in the city here in London. And of course, where we think we can go, our technology is literally shippable in containers. We currently build all around the UK, but of course, our product is extremely applicable in other markets like the US, Europe, Australia. We're also talking with a few people in the US to try and bring microfactories over there. And so, right now we're expanding in the UK, but we're also looking at other territories to expand to. And this is really where we want to end up, which is, essentially being our own tech-enabled home builder, building sustainable housing through this revolution in digital manufacturing. Um, and maybe to end, Bruce, just as a little mini announcement, we've just as as we've as we've been expanding what we do and shifting our brand a little bit, we've just rebranded and created a new website. So our new Facit Homes website was released on Friday. That enables you to look at two sides of it now. So we have a homeowner side. So we're continuing to deliver single one-off homes to consumers, but we also have a developer side where you can find out a little bit more about some of those projects that we showed today, some of the things that we have in the pipeline, our capabilities, the new microfactories under the build process. You can find out a bit more information about how we build and the systems that we build with, which is all released as of Friday, right, Bruce?
Yep, that's right. New look, new brand. We're now Facet as well, rather than Facet Homes, which is partly to clear up any confusion on the development side where we sound like a developer. So actually, Facet is now a little bit more precise because we don't necessarily sound like a developer ourselves.
Exactly, yeah. Um, Let me see if there's any questions in the chat. If not, I'll ask you a few questions, Bruce.
There
Let
is
me.
one question here, which is the framing part of the assembly, or must the framing be built first prior to wall installation, or does it depend on the project scale? Um, I think that means, well, so basically the framing is the chassis. It's all structural load bearing. That's the part that we manufacture using the CNC machine. It's either made in small components, which are hand built into the project, or we stitch them together into bigger sub-assemblies, which are then craned into position. So really, in terms of the choice on that, it really depends on scale. You need a bigger bit of infrastructure to build sub-assemblies, so you're not going to do it for one house. For our smaller projects, the bigger projects, you would definitely do it because you want to reduce the working at height and the risks associated with that.
Yeah, maybe I'll ask you a few questions that we often get asked.
Sounds good.
Talk about the current houses and new houses. People always ask, like, can you get mortgages on a timber frame house and warranties, all that kind of stuff.
Yeah, so all of our customers have mortgages. We have to deal with the realities of getting building control, getting warranties, lending provision, going all through that technical process is part and parcel of what we do. If we didn't do that, we wouldn't be able to sell homes because we have normal customers who have normal lives and need to borrow money.
Yeah. Also, maybe Bruce talk about collaborative side of it. Like,
Yeah.
do we in the past do we collaborate with architects if there's a developer watching and they have a project, can they come to us with an existing design? How does that work?
Yeah, so historically, we have taken on projects that are designed by others, but those tend to be historically that has been less collaborative. So about 80% of the projects on our website are designed by us and built by us, about 20% designed by others and then built by us. But now in this new phase on the development side, we're working much more collaboratively. We select architects who we have some kind of relationship with. So we're starting to form long-term relationships with particular architects. Um, and or we can also in the same way build stuff that's already got planning permission. So yeah, it's a slightly different way of working, but it's the architects who we are starting to work with at the moment, they don't treat us like a contractor. They think of it as a partnership. Where they understand it as a concept, as a process, and we're helping them understand the tools and get the most out of it, rather than architect says this is what I want, you go and build it as a contractor.
I think we got another comment where someone's asking what's the connection detail between the components, I think.
So it's quite traditional. It's well, it depends what it is. If it's between the wall and the floor, it's there's a timber sole plate. It's what you call skew nailing. So you basically just traditional timber frame nails, bang diagonally, stitch across like that at centers. That's what ties it all together. But it's really the material itself. That holds itself together. So if you look at the components, the connections between one sheet and the next one are mortise and tenon. They're really tightly manufactured. Then there's nails that hold the parts together, but they don't really. It's the timber does the work. The nails are just kind of like helping it hang together a little bit more, and then we have more nails and we put more components together. So, but it's a lot of what we do in practice follows very tried and tested methodologies or ways of working from the construction sector or timber frame or whatever. We try and revolutionize the process more than we do the actual product in terms, particularly in terms of building science. We try not to reinvent the wheel.
Maybe also talk about the plywood that we use, like where do we get it from, and
Yeah, so
it's
we
pretty sustainable, right?
Yeah, I mean, you couldn't choose a more sustainable product. So we buy in plywood that's grown in Finland. They use hydro to operate the machinery. It's got a bio-based glue, which is formaldehyde free. The waste that we get from it is A-grade wood waste, which means you can do anything you want in terms of recycling. You can chip it into pellets. You can put it into paper pulp. Um, and it's about as green as you could possibly get. Generally, we try and reduce carbon throughout the whole process, particularly in use of concrete, choice of insulation materials, etc.
And probably our most commonly asked question is, how long will the building last?
Yeah, it's funny that, isn't it? Yeah, it's funny how you get people ask this question because some of the oldest buildings in the world are timber. Timber buildings last as long. And if you think about a very traditional house, let's say like a house builder might have built 20 years ago, blockwork walls, fine, but its roof would be timber, its floors would be timber. There'd be a lot of timber elements in it, and actually the most vulnerable part of any building is its roof, which is timber. So as long just like any other like masonry walled building, if you maintain it, it'll last indefinitely. I mean, it the way that the material's manufactured, it will literally last forever if you maintain it. It doesn't get to a point and just degrade.
Yeah, I think when you see one of the components in person, it's like, or touch it, it's so incredibly rigid and strong. Like, it's a strong, hefty
It,
component.
it is. In fact, in the structural testing that we did, they're very, very stiff. Much more stiff than a traditional timber frame, which is a bit more lightweight. So the racking strength, in terms of we had to do racking tests where you kind of put it on the angle and try and break it. We actually broke the machine three dimes. They're that strong. It's quite surprising actually because they're so light, but they're incredibly strong.
And maybe to wrap up, if someone wants to get in contact with us, they're architects that want to collaborate, a developer that has a project, a landowner that wants to build some facet houses with us, where's the
Bring it
best
on.
way to reach out?
Just reach out to me or Ollie. You can reach out to me, Bruce at Facit Homes, or Ollie or info at. I'd love to hear from you. Love to talk about projects.
Yeah, reach out to us on LinkedIn is always a good one.
Yeah,
Info at facet-homes.com will come to us and we'll check it out. And like we say, we can kind of do anything. We can work with existing design. We can take a virgin piece of land and try and take it through planning. We can take an existing project and existing design and develop it. So yeah, I think there's plenty we can do.
yeah, indeed.
All right, Bruce. Well, thank you so much for coming on. This is our first episode, so
No
this is
worries.
a new one for us, but I kind of like the format. Simple way to just get out there. Um, so yeah, thank you for coming, and
No
guys,
problem.
we'll see you at the next one. We're going to follow this up in a couple weeks, most likely with Sylvia, who has done some of the Twin Motion course. She's going to come out with an Unreal course, and she's going to talk to us about her journey to Burning Man and designing and building from here in the UK all the way to Burning Man and the installation that she did. So we'll see you guys in that one. But otherwise, Bruce, thanks again, and we'll see you guys in the next video.